morning, everyone. How's everybody doing? Awesome. So now let me introduce you to Mr. Jeff. He'll be educating us on PyScript, interactive documentation with PyScript.
Good morning. Let's talk about making your documentation interactive with PyScript. On the screen now is everywhere you can find me online. In particular, if you go to jeff.glass/PyCon2024, all the slides, all the demos are there. There'll be a QR code later. For those of you who like such things, I see a lot of phones snapping. QR code will be there as well. So here's the pitch. I'm going to guess a lot of you in this room are interested in documentation, and I'm going to bet your documentation looks like this. It's not your eyes. I've blurred out that right part. The point here is basically all documentation looks like code block, text, code block, text, code block, text, right? This is the form we've settled on for documentation. Bonus points if you can tell which part of the Python docs this is. Come find me afterward. And I have a problem with this because we'd all rather be running code than reading code. Right? If we're in the documentation, we have something we're trying to do, and we can't, and we want to write it correctly, and now we have to go and read somebody else's code to make it work? Ugh, bummer. That's not to diss anybody who's writing excellent documentation code. I love you, but I have a tool that I think we can use to do better. Here's a snippet from one of my favorite packages, which is the rich formatting library for the terminal. This is actually a screenshot from the library. It just says, if you print a string, it will render console markup. Here are some examples. It does console.print various data structures, right? You get print a list, print with maybe some formatting, print the locals dictionary. This is all the doc says. Okay, this is cool. What if I want to try this? Well, okay, so I've got to install rich, which means I probably need a virtual environment, and then like, which version of Python am I running, and how do I instantiate this object? There's a really long road between seeing the code sample in the documentation and actually running it for yourself, which is a shame because the results are often really cool. How many times have you been writing your docs and thought to myself, oh, when users run this, they're gonna love it. They're gonna love my package. But there's a long road between your documentation and what actually appears on the screen. So here's what PyScript allows you to do, is to turn that piece of static code documentation into an interactive code cell that runs in the user's browser and actually runs inside your documentation website. So in the rich documentation, for example, if we were to execute that code, the user would see the results of it running on the page, no downloads. Right? This is also an interactive code cell, so if users are editing the code, they can see their changes reflected live on your site. Right? This is the fastest road from getting users to seeing your code sample to actually running your code with no downloads, no installing, no nothing. That's the pitch. So today we'll talk about making your existing static documentation interactive using PyScript. Here's what we're looking at. We'll do a quick who am I? We'll do a refresher on what the heck is PyScript. We'll go into details of the code editor, which is that cell we were looking at a moment ago. We'll talk about how you integrate this into Sphinx, MkDocs, or a raw HTML documentation. We'll talk about deployment to GitHub Pages or readthedocs or whatever host you prefer. And then we'll close out with some of the cool things that PyScript can do, and then some of the limitations of running Python in the browser, because not everything is possible, just most things. Yeah? All right. Who am I? I'm Jeff Glass. I'm one of the PyScript maintainers. I'm also the author of PyScript.recipes, which is a site that has PyScript and Pyodide snippets to help you run Python on the web better. In my day job, I'm the senior exhibit development engineer for the Griffin Museum of Science and Industry in Chicago. The through line there, if you're wondering how I ended up at PyCon, we have 783 interactive things at our museum. So my whole life is about how do I take a thing and make it interactive to teach someone something. That's the through line. So what is PyScript? PyScript's pitch is write Python in your HTML. If you've ever written any HTML, and you may have, you'll know that the script tag is normally how you run JavaScript. You'd enclose with square brackets the script tag, and any JavaScript inside will run. PyScript makes it possible to run Python in your HTML. Any scripts with a type of Py run when your page loads. And I want to be clear, this is truly the CPython interpreter that we all know and love running in the user's browser. So we're not cross-compiling to JavaScript and then running. Ooh, JavaScript. we're not shipping your code, your Python code, to a server and running it and then returning the results. We are really running the actual CPython interpreter client side in the user's browser, so all the data stays in the client. That's made possible because we're based on top of a couple of runtimes, actually, but especially the pyadide runtime, which takes CPython as we know it and compiles it to run in WebAssembly using a program called Inscriptum. We're also based on top of the MicroPython runtime, so you can do any of this with MicroPython as well. MicroPython is a slimmed down, very fast, very tight version of Python. It's not CAPI compatible, so no NumPy or anything like that in MicroPython, but it is blazing fast. And then on top of us, we have frameworks like LTK or Starfire for those who want to write Python in their HTML but do it in a reactive way or in a widget framework-based way, like think like Vue or React if you know those frameworks, but in Python. Right? That's the real quick and dirty of what PyScript is. How do you install it? You don't. You just make sure that you point to your CDN, I guess not to your CDN, to our CDN on your page, pointing to the latest release. And after you include that one script tag on your page, any scripts with a type of Py will run Python when the page loads. It's not guaranteed to be good Python. If you run this code here on my computer, this locks up my browser tab for about 7 seconds, long enough for Chrome to give me that, do you want to kill the tab? So it will run just like JavaScript runs in the main thread. It has full access to the page. You can react to events. Basically anything JavaScript can do, this allows you to do in Python. The key tool that PyScript provides that we're going to make use of today is what we call the PyEditor, or the PyEditor cell, which is this sort of graphic code cell, much like a Jupyter Notebook cell that we saw earlier, that runs the code that's contained within it when the user clicks the little green play button. And it will run it in a worker thread. And we'll expand a little bit on that later. But basically what that means is if you're running code in a PyEditor, it won't lock up the user's browser tab like our billion-line loop will do. It'll make sure it is non-blocking in a very important way. And like I say, more details coming. Also, one little parenthetical, I mentioned we can run on top of pyadide, CPython as we know it, or MicroPython. All of the examples in these slides, if you replace Py with MPy, you switch to MicroPython. So if you had a MPy editor, it would run in MicroPython. We're going to focus on CPython as we know it today, but that's a really cool sort of Easter egg for you. Let's look at how you actually get these editor cells onto your page. And I'm going to focus at a sort of conceptual level, sort of a high level to start with, and then I'll show you how you actually would inject it into Sphinx or MkDocs or HTML, depending on what your deployment is, right? So we'll start high level, and we'll work our way down. There's 3 properties of editors that you'll want to know. They are environment, configuration, and what we call set of tags. Environment. By default, all of these PyEditor cells that you stick into your page run in their own copy of the CPython interpreter. So if this was a vanilla page that you'd integrated this into, when you click the run button on that first cell, it will bootstrap a copy of the CPython interpreter in a worker thread. It will set X to 1, and then it will terminate. Or really, it will just sit around and do nothing. If you hit play on the next cell, it will bootstrap a new copy of the CPython interpreter and then try to print X, and we'll get a name error, right? Because we've essentially, you can think of it like typing Python into your terminal again and starting a new copy of the interpreter where X is not yet defined. This can be helpful for some things, right? If you think about your own documentation. I see some of you thinking like, oh yeah, is that okay? So I could split multiple examples onto different parts of the same page. Absolutely. But of course, sometimes it'd be helpful if cells shared state. And for that, we can use a shared environment. And all a shared environment means that 2 cells with the same environment run in the same copy of the interpreter, right? So if I were to run these first 2 cells now, x equals 1 and print x, it would print 1. If I had a cell in another environment and tried to print x, another copy of CPython, I'd still get a name error, right? So environment is just another word for a copy of the CPython runtime. And you can choose to group your cells all into one environment or to multiple separate ones depending on your page. And again, I know some of you are thinking, this is cool, you haven't showed me the code, how do I actually do this? We're getting there, we'll start high level and we'll work our way in. Configuration. There's a lot that can go into a PyScript configuration, but the 2 most important things for our purposes are installing packages and loading files. You're going to provide either a TOML or a JSON file to your PyEditor, and it'll allow you to install Python packages or to load files into your system to make use of. The packages key in your TOML or JSON file, and this is TOML, can load packages from 3 different places. It can load packages direct from PyPI, right? So any pure Any pure Python package will load into the browser. It can pull from the Pyodide repository. The Pyodide folks have done kind of an amazing job pre-compiling a bunch of the scientific stack to work in WebAssembly. So things like NumPy and SciPy and scikit-learn and AstroPy that have big C or Fortran components to them that aren't super happy compiling to WebAssembly natively. The Pyodide team has said, we'll take care of the hard part of building that. If you type pandas, for example, into your packages key, it will load pandas into the browser from the Pyodide repository because they've already made it work. And finally, you can load wheel files from a URL. This is super helpful if you're building documentation alongside a library, because you can build your wheel file for your package you're developing and load it directly into your documentation, right? So you give it the URL of a wheel, and it loads away. The other thing you can do with configurations is load files for the interpreters to use. This is a super key element of how PyScript operates. When you bootstrap a copy of the CPython interpreter, it comes into existence inside of a virtual in-memory file system that exists within the browser tab itself, much like JavaScript objects do, right? When you close a browser tab, any objects you've created get destroyed. And similarly, the CPython interpreter you might have created gets destroyed, and all the files you might have created, with open file type read as F, write to a file, that exists in this virtual in-memory file system that only exists as long as your browser tab exists. So the files configuration is how you get files from the world, from the web, into that virtual in-memory file system for Python to interactive. And it just takes a succession of URL to file location pairs. So this would take the data from, I have a typo here, from content/my-data as a URL and bring it into a local file called data.csv, where we could do something like this. So this is straight out of the pandas docs. If I wanted to do some pandas documentation interactively, I could make sure that pandas was in my packages key, and then I could use pandas readCSV function to pull from that virtual file system, just like I was local to disk, and then print out some data in my data frame, right? So fetching packages and installing them, and then fetching files and using them for data, yeah? Let's actually take another example from the pandas documentation. This is a snippet that says, use dataframe.head and dataframe.tail to view the top and bottom rows of the frame respectively. And the example is printdf.head, right? The documentation just wants to show you, here's how you grab some data and print it out. Of course, if we were to run this alone, we would get a df not defined, because again, when we run this cell, we're bootstrapping a new copy of the Python interpreter. So we don't have df defined, we don't have anything installed, we don't have anything imported. So what are we going to do about that? Well, one thing we could do is type all that into this editor cell for the user, but then they would see, 20 lines of code, import pandas as PD and set up a data, right? That's not the most cumbersome. So what we'll use is a setup tag. And a setup tag is just a way to pre-run some code when the interpreter bootstraps. This is ways you can, import libraries, you can set up objects so that the visible effects for your user are as clear as possible, right? So in this case, I might have some quite long code importing pandas, maybe NumPy, setting up my data frame object, and so my code example that the user sees can just say print df.head, and when I run it, it will actually have data backing it so my users can see what we're doing. All right, so that's the three big concepts before we get into implementation. Each environment is a separate copy of the interpreter. You can load packages or files into your environment using one of those configurations or a configuration file. And you can pre-run hidden setup code inside of a setup tag to do imports or set up objects that you don't want your user to see. Right? I've deliberately held off on showing you the HTML for this, partly because it's a little bit cumbersome to show on the slide, and partly because I have a feeling most of you are not writing your documentation in raw HTML. At least I hope not. There are better ways. But just to show you what's happening under the hood, if that is your use case, all a Py editor is in HTML, one of these cells, is a script with a type of Py editor. We can give it an environment with the env attribute. To provide a config, we provide the HTML tag with a config attribute. To make it a setup tag, we give it the setup attribute. We can assign it an env. So if I had these two cells on my page, I would, in the background, load a configuration, define this function foo, and then the user will just see a cell that says foo, and that they can run it, and it will print hi. Right? That's the gist if you are doing this in raw HTML, right? If this is like GeoCities era and you're doing it all by hand. But I think most of you are probably using some kind of documentation builder, right? Sphinx and MkDocs being two of the most popular. And if you are, good news, there are ways to integrate this without writing any HTML by hand. There's the Sphinx PyScript extension and the MkDocs PyScript extension. And I want to show you how to integrate this idea with both of those systems. Getting Sphinx PyScript running is super easy. You pip install Sphinx PyScript, you add Sphinx PyScripts into your extensions in your conf.py, to that configuration there. And this will add a number of new directives, which is, if you're not familiar with Sphinx, it uses something called restructured text, which provides these directives, something to tell your documentation processor to do something new. In this case, add a PyEditor cell to the page. And you can see that the options for this PyEditor are very similar to what we've been talking about. You can make a tag a setup tag, you can specify its environment, you can give it a configuration. Any setup tags are hidden, any non-setup tags are visible. So here's a really simple build of the most boring documentation in the world where we want to explain to the user to print X. Actually, it might not be, actually. There's probably a section of the Python docs that is literally print X, because we were all there at some point. All right, take it back. This is the most important documentation in the world that you could run in the browser. So just to take you sort of from what you would have had in Sphinx to what you would have with the plugin, this is how you would format a code block in Sphinx with that double colon, console.print123. And if we were to do it in Sphinx PyScript, we'd have a setup tag in an environment. I've called it rich, you can call it whatever you want. We'd have a configuration which would load the rich package for us to use. Inside that setup tag, right, we're gonna do all of our imports and our object setup that we don't want the user to see. And we will create a console object for the user to use. And then in our visible PyEditor, we would do console.print123, right? So going from a slightly more condensed syntax to a more verbose syntax allows us to add these editable cells into our documentation. For those using MkDocs, very similar process. Pip install MkDocs, and in the plugin section of your MkDocs.yaml, you add the plugin to your plugins key. The syntax in Markdown or in MkDocs is a little bit different. We use the adders list format, which basically says any classes that I put inside of these curly brackets in a code block will be added to the HTML that is generated, and then we do some post-processing to add the cells. So this is exactly that same very important example we looked at a moment ago, where we set X to 1 in a setup tag in a hidden way, and then visible to the user, we print X on the page. Similarly, let's move ahead to here, because I want to make sure I highlight this. In the MkDocs plugin, in contrast to the Sphinx plugin, we by default transform all the code blocks on your site. So if you install Sphinx PyScript and build your site, we will try and transform every single code block on your page into an editable cell, which may or may not be what you want. So we provide this selective option. If you set selective as true, all of your code blocks become opt-in to becoming editors. So if you add the .PyScript class to your code blocks, they'll become editable. If you leave it out, they won't. This is probably the better way to go. So we may flip the defaults, and I'm a maintainer on this project. We might flip the default so that cells are opt-in rather than opt-out. Because when you enable this, you end up building thousands and thousands of code cells in your first build, and I suspect that's not what you want. There's sort of two different tactics we have going on here. The Sphinx PyScript extension, you write your editor cells directly, so you're writing directives that represent editors. So whenever you build them, you get editor cells. In MkDocs, you're writing code blocks that are then transformed into editors. So if you build without the extension, you just get vanilla code blocks. And these are sort of two different ways you could think about putting this stuff in your code, and I don't know which one is better. And I'm hoping you'll find me afterward and tell me, or try this in your code and see what you like. This is all quite new. You might remember PyScript launched here like 2 years ago, and these products are all quite fresh. So if you have feelings about using this or thoughts about how it could be better, please do come find me or the rest of the PyScript team, because we'd love to hear about it. Let's talk about implications for deployment. Some popular places to deploy docs: GitHub, readthedocs.io, or in a static site in like an S3 bucket or on Google Cloud or something like that. Let's talk about what it means to use PyScript in one of these locations. If you are deploying to GitHub or readthedocs or a static host using one of the extensions that we just talked about, you don't have to worry about anything. It just works. This is really true. You can't just install this plugin and rock away, and it will run editor cells on your site. If you are one of those people who is like, well, I don't use a build system, I write in vanilla HTML, There is one consideration, which is those worker threads that I talked about, and I want to expand on that now. This is something that the plugins take care of for you, that if you're doing things from scratch, you'll need to think about yourself. Just a little bit of webbishness this morning, a little bit of how the browser works. Well, we'll try and make it brief. In the browser, as I mentioned earlier, the model is one tab is one thread. If you open a tab with Gmail on it, you get one main thread to do everything, to render the page, to run JavaScript, to execute events, to load new links. You get one thread per tab, which is an interesting model and makes it hard to do things like run a bunch of different Python interpreters that could block that thread. That's not a super good user experience. So what we do in PyScript for these editor cells is spin up a bunch of what are called worker threads. And they're exactly what they sound like. They are threads that do work. They have one key limitation, however, which is that they are not allowed to access the content of the page itself. They don't get to see the page, they don't get to see events, they can't be reactive. And this is a problem because what we want to do is have something happen on the page, tell the worker thread to do something, and then come back and report what it did. So we use a synchronization method called the shared array buffer. And I know we're deep in the weeds here. If these words mean things to you, you're like, oh cool, he has a solution for me. And if these words don't mean things to you, don't worry, the plugins take care of it for you. The shared array buffer is just a synchronization mechanism between threads. And after some very exciting vulnerabilities were discovered in 2018, remember Meltdown and Spectre, which were sort of leaking data from a timing attack on the side channel, they figured out this was possible through the browser as well. You could manipulate this shared buffer to leak data back across the web, which is bad. So now the shared array buffer is only available in what are called secure contexts. And I put this slide sort of full of keywords up here because if you are having this problem, these are all the buzzwords you'll see in your error message. So you come back to the slides of this talk and say, oh, that's how Jeff said to solve it. You can solve it in one of two ways. If you're a web person and these headers mean anything to you, and they don't mean that much to me, these are the headers you need to set on your server to prove that you are operating in a secure environment. No judgment if these mean things to you. I'm just not a backend person. The other thing you can do is provide essentially a shim inside of your HTML that sets these headers for you. Two popular ones are COI service worker or mini COI. Links to all of this, again, in the documentation. And all that looks like in that case is making sure that a script tag pointing to one of those services, like mini COI, ends up in your HTML. This is all these plugins are doing, is essentially shimming out these headers just so it operates in it thinks as a secure context. If you're doing it in HTML, make sure you're providing your own solution. And like I say, this is probably not a problem you're going to encounter, but when you do, the error message you get is something like, shared array buffer cannot be used in insecure context. And you go, I don't know what any of that means. And this is what that means. All right, let's wrap up with some words about what PyScript can do and what PyScript can't do. Things that just work when you're running Python on the web. Almost all the standard library just works. Most of it's pure Python, and so just works, and a lot of it is written in C, which we can build to WebAssembly, which is very cool. I mentioned the scientific stack, so NumPy, SciPy, Pandas, scikit-learn, scikit-image, AstroPy, a bunch of the heavy computational libraries just work. So if you want to have your website running, scikit-learn on it, doing some data analytics, you want to show that off, but you don't want to run a server that's running scikit-learn, just do it on the client side. Just push it to them. A lot of other common packages have been made to work with PyScript and Pyodide. Things like OpenCV for vision recognition, Pillow or Bokeh. Panel actually works with PyScript, so you can add panel widgets directly into your website, which is pretty cool. Things like MyPy and PyTest now work in Pyodide, so if you want to have your users write some Python code on your website and then you run PyTest tests on it without ever shipping you any of your code, that's possible. And most pure Python packages from PyPI also just work. Rich, that we've been using as an example for today, is a good one. That is written in pure Python, and since we have a copy of the CPython interpreter in the browser, it just works. Let's talk about things that don't work or that are different. From our description earlier, you may have guessed that threading works a little bit differently in the browser. You don't get access to spawning new threads or things from the multiprocessing library. I think they're in there as stubs, but if you try and call any of the actual objects, it'll throw up on you real fast. We don't get native windowing controls, so things like curses or tkinter that are trying to grab the OS by the windowing parts and make applications are not going to work natively inside of a browser window. Things like Turtle or the idle editor, right, are not fully available. There are some cool adaptations of Turtle, by the way, that do work in the browser. I saw Joshua Lowe just earlier. He's got a cool implementation where you write Python and it translates it to JavaScript and then runs it, I think. Josh is going, I'll talk later. But some of those things are not available natively. And then networking, of course, works differently when you're running code inside of a browser window, right? You can't, I don't think you can, run a server in your browser tab that my laptop can connect to. That seems terribly insecure. That's not possible. So things like sockets need to be patched or handled differently. Now that said, that doesn't mean it's impossible to run server-side code on the client side. And this would be stretching our topic a little bit to get into, but I want to just touch on it because it's a very cool option. It is possible to take stuff like FastAPI or Flask or Django that's meant to run server-side and run it using what's called a service worker. That's a little piece of code that you tell the browser to store, and when the user makes web requests, use this little piece of code to answer them as opposed to going back to the server. It's a way a lot of like offline web apps work, right? If you've ever loaded up Google Docs and you don't have a web connection, what it's doing is it's hitting the Google Docs URL, and a little service worker that it's cached is feeding you that content back instead of going back to the web, right? So that makes it possible to run things like FastAPI and Django client-side for the purposes of documentation without having to have a server infrastructure at all. That is fairly involved. I don't want to pretend like that's necessarily simple, but I think Fabio did this experiment with Sebastian at last PyCon, yeah? Where they got FastAPI running in a service worker, so they have the FastAPI docs reacting with a real FastAPI server without a server, which is very cool. So if you're interested in that, come find us and come find the PyScript team. Other things you can do with PyScript, and again, I'll touch on them briefly before segueing to where you can learn more. You can also run a fully interactive Python terminal. Like if you want a proper REPL to play around with your library in, it's totally possible to spawn one of those. Not as common, I think, in a documentation sense, but if I'm wrong, and that is something you want to learn about, you are in luck. There is actually another talk going at the other end of PyScript documentation with Valerio at 4:30 in room 301 through 305, who's focusing on sort of the fundamental aspects of PyScript that make this possible. So diving deeper into those HTML elements, into the PyTerminal, into worker threads. For those of you who are building bespoke documentation systems for more complicated things, maybe a scikit-learn or something like that, this would be a really cool session for you to attend. And then actually immediately after that, we have one more PyScript talk today at 5:15, all in the exact same room. Lukash is talking about building in-browser 3D experiences with WebGL and PyScript. We saw a little taste of this on a PyScript community call a while ago. That one is worth checking out. If you're looking for rendering things in the browser using Python, super, super cool. That's the talk. That's the QR code where all the links are. I'm Jeff Glass. I'm at PyCon 2024, and we have time for one question before we wrap things up if anyone has one. If you've got a question, please find one of the microphones just there. I see you in the gray shirt there. You'll be our one. And I will be in the hallway afterward and around the con this whole time, so come find me if you've got questions.
Great. Really interesting. I maintain a Python API that is basically it's completely offline. I also only include this API in an embedded Python interpreter. Is it possible to use this, like to embed this within, like, the CPython API or within, this type of setting?
Yeah, if you have an API that's being served by a CPython process, essentially, but you're normally just doing it locally, and it's pure Python, or are you doing like a C extension sort of thing?
So they're essentially packages that are like bootstrapped. We have our own bootstrap method for the embedded interpreter. Mm-hmm. So essentially, we're using the embedded interpreter. We're only able to use the API within that interpreter.
Gotcha.
But we do, like, I maintain the interpreter itself too.
Okay.
So.
I should say we should talk.
Okay,
I don't think
cool.
it's impossible. You might end up compiling that interpreter to WebAssembly to get it to run,
okay.
Which is not as miserable as it sounds. There's been a ton of work on the Inscripton side to make that possible. Okay, cool. If it was pure CPython, I would say yes, absolutely. With a custom interpreter, we should talk, and you can look at the back end of how PyScript is doing it. Maybe we can work something out.
Sure, thank you very much.
Yeah, cool question. Thanks, everybody. Have a great PyCon.